In our last week's episode, at some point we referenced NSA's egotistical giraffe, and that was the inspiration behind this episode. So welcome to the Spy Collection. Here is Anastasios, and as we typically do, we reconstructed the slide deck that was originally leaked by Edward Snowden to be easier to navigate through it. So let's go. That was the introduction presentation for this program, titled Peeling Back the Layers of Tor with Egotistical Giraffe. Note that it says that it was classified in 2007, but based on the information listed in this presentation, specifically some software versions, it's obvious that although it was initially created in 2007, it was updated at least once in October of 2012. This was developed by the Data Network Technologies branch, which was under the Office for Tailored Access Operations. That was a very small department in NSA dedicated to developing hacking methods for cases that the mass surveillance systems of the agency weren't covering. And one of them was, and quite possibly still is, the Tor project. This presentation was originally classified as top secret and compartmentalized for comment only. So even people with top secret clearances didn't have access to it unless explicitly read in. This TAO presentation covered what is Tor, and for pedantic viewers, you are right, NSA has made a typo. Tor isn't an acronym, so it's not written with capital letters. And this is such a common mistake that literally the Tor project has an entire page dedicated to it. Alright, so after that, we have the, according to the NSA, Tor problem, followed by two NSA top secret programs, codenamed EGOTISTICALGOAT and EGOTISTICALGIRAFFE. And if you'd like to know how those code names are produced, check the equivalent Tradecraft Sunday episode. And it was closing with some future developments. So Tor project is an open source anonymization network, and that's an important distinction to make. Tor is not designed to protect your privacy, for instance if you use your personal data on a website, but it can anonymize the connection, so it's designed for anonymity, not privacy. This creates what NSA called here the non-attributable network activity. Basically, you cannot tell who connects to what simply by inspecting their network signals. And that allows circumvention of nation-state actor spying and censorship capabilities, which is actually what Tor is designed to be used for. Even NSA hackers themselves wrote that its users include dissidents that try to evade the control of authoritative nation-states, to privacy-conscious people, but also bad actors, like terrorists. So in a very, very oversimplified manner, the Tor client from a person's device is connecting to a Tor entry node, and that node does a magic and forwards this communication to other Tor nodes, the Tor relays, and eventually that leads to a Tor exit node that sends it to the actual destination. This way the client traffic is only seen from the client to the entry node, and the destination only sees that Tor exit node that connected to it. To protect this communication, each layer is encrypted, so no node can decrypt what the client requested. Basically, they act as dummy forwarders, adding encryption layers that are peeled back, so that the Tor exit node sends the message only with the encryption layer of the original client. And to make things worse for spy agencies like the NSA, it's extremely easy for anyone to use Tor without any technical expertise, or as NSA described it, it's idiot-proof. And of course, all of that architecture is something that no signals intelligence agency likes, since it creates a method to hide from their collection capabilities. And this is exactly what NSA called the Tor problem. So let's see how NSA tried to address this challenge. First, NSA identified all the versions of web browsers and operating systems that Tor client used at the time. That was in 2012. As it says here, the release number of Firefox browser tells when the release was built. However, the Tor browser's release of Firefox had a build ID of 0. That small mistake from the Tor project gave NSA a method to fingerprint who had Tor installed on their device and who didn't. Of course, that's now fixed, but it gives an idea into how NSA hackers tackle such challenges. As NSA stated, what Tor cared is to make Tor users indistinguishable from non-Tor users. But in this case, NSA only wanted to target Tor users, and thanks to that build ID mistake, they could. But even if they had a method to identify them, they still had no way of spying on their traffic. So naturally the next step was the exploitation. As it says, Tor has been very thorough to remove as many dependencies as possible and explicitly advise users against installing third-party plugins. That left the NSA with only one option: discover a native way to hack into Firefox itself, the code of the browser from which Tor was based on. Here NSA reveals that they already had some zero-day exploits for Firefox, meaning hacking tools exploiting security holes that were unknown to Firefox. The first, codenamed ERRORNEOUSINGENUITY, or among the NSA hackers simply referred to as ERIN, was a hacking tool that was taking advantage of a security flaw unknown to Firefox. Based on the fact that TAO had a nickname for it, we can speculate that they used that to hack into several other targets using Firefox. The downside of that, it was that it was only working on that version range. That was basically any Firefox browser released from June 5th, 2012 until October 26th, 2012, almost certainly the latest release at the time of this presentation. And the second top secret hacking tool NSA had was codenamed EGOTISTICALGOAT, or internally referred to as EGGO, which not only covered all the versions that ERIN did, but also covering older versions, going all the way back to version 10, that's from January of 2012. We read that EGGO was a type confusion security flaw in Firefox's E4X, that's ECMA script for XML implementation. Without delving into all of the exploitation details, a type confusion vulnerability is like a program mistaking one kind of data for another, which can make it behave unpredictably, and a clever malicious user could exploit that to force it to do something it wasn't designed to. In this case, the vulnerability was found in an old Firefox's XML handling feature called E4X, so NSA hackers could craft a special packet that would trigger this behavior, and through that, it enabled arbitrary read-write access to the process memory. In layman's terms, allowed the NSA to read or write code on the target system without any action required from the user. In hacker lingo, this is called a remote code execution, and it was performed by the CT-types module. Note that using that, NSA could hack literally any person worldwide using Firefox, and most likely they did, anytime they needed. Immediately after Snowden's revelations, a Firefox software engineer from Australia raised it in the Firefox community, and they agreed that since this leak didn't explicitly mention the vulnerability, but mentioned it was in the legacy E4X code, quoting Gary Kwong of the Firefox team, "It's about time to completely remove E4X forever and ever, and ever." So we know that this is what killed NSA's EGGO hacking tool. But back to the presentation, the EGGO hacking tool had some issues. Given that it wasn't exploiting Tor itself, but instead exploiting Firefox, it was impossible to distinguish what operating system the target had before hacking into their system. They couldn't know the Firefox version running before hacking the suspected target, for the same reasons. And they couldn't know the platform it was running on either, again before hacking into someone's system. But according to the NSA, for all of those, it was fine. It just changed the process so that instead of first identifying the target and then hacking them, to hack first and then identify if they are a target or not. Alright, but what happened assuming they found the target using Tor? First, NSA managed to hack into the Firefox browser, as we read here, using the method we just described, but they failed to do the same on the Tor browser or install the backdoor they had for such cases, that it was codenamed FINKDIFFERENT, or FIDDI for short. And the root cause for that failure was something called pre-filter hashing, which was blocking both the egotistical giraffe, the exploitation, and the FINKDIFFERENT backdoors of the NSA. But of course, NSA's hackers wouldn't be stopped by that. Their solution? Disable pre-filter hashing and install an NSA backdoor codenamed FUNNELOUT. FUNNELOUT was basically exfiltrating traffic from the target system into NSA's infrastructure so that they could collect it and analyze it. And since all of that was happening on the client system, It didn't really matter if they were using Tor, VPN, or anything else. They were intercepting whatever the system was sending and receiving, completely outside of Tor's anonymization network. Of course, that tradecraft had some OPSEC risk to consider, since this method required to hack first, meaning using this top-secret capability, and then look if it's a valid target or not, or using NSA's lingo, a pre-play attack. It means that there was increased risk that some security solution that the target might have, think of antivirus, firewalls and so on, could detect this and compromise this hacking tool. The other risk was that their hacking tool might end up in the hands of an adversary, since all nation-state actors set up fake networks, called honeypots, to see how their adversaries operate and also perform thorough digital forensics in case of suspicious behavior in any part of their infrastructure. So NSA hackers closed this by raising the question, does it worth risking this hacking capability? And this last one is something that even to this day, SIGINT agencies deal with on a daily basis. Even if you are able to hack virtually every single device in the world, would you risk losing this capability by acting in a reckless manner? As you can probably guess, there have been many heated discussions in meetings in agencies like the NSA exactly for this, in case there is a need to hack into a target, but the agency isn't willing to burn a major capability. And probably now you have a better idea of the challenge that TAEO was dealing with, how they were going after them, some context behind those cryptic code names, and understand some of the realities of the cyber espionage game. A game that today is more relevant than it has ever been. So despite this being from 2012, it's a great example of what happens in secure facilities and why we keep on saying that nothing is as it seems.